All right. Okay. I'm back. I'm recording now, and I don't think it will actually take the audio from that's coming from my computer. I think it'll only take my audio, but that's fine. So you guys can see Putty right now. Awesome. All right. And can you also? I guess you probably can't see the Prelab, but I'll assume you guys have the Prelab in front of you. Okay. So I'll just go through like my thought process on it. Obviously, first I just include standard.io.h. That's always the first thing I do, and then I just go ahead and start with main. And I just start here. And whenever I'm writing a program, I start with like thinking, what do I want it to do? And so what we're supposed to do, it wants us to so we need to, I'll just read through the kind of description. We need to declare an array of integers with 256 elements. We'll have to call a function to initialize it and call a function to print it. The only things we're allowed to do in main are declaring, printing header information, and calling those functions. Well, I'll go ahead and start by declaring the array. And it'll be an integer array. And then I'll just theoretically call the functions. They don't exist yet, but I'll call them. So we'll have an initialize array, and then print array. But there's actually going to be something weird going on because the print array function is supposed to be a void function, and the initialize array is actually going to return an integer. And I can't remember where it says. Yeah, in the where it says prototypes for the functions you should write, where it says int initialize array, and it gives you the parameters to put in there. It says this function should return a count of how many elements were initialized. And so if we were to say just simply like, let's just say for example we had an integer x and we set it equal to whatever this result was, x would become the number of elements in the array, because whatever a function returns, that's its value. And so for now, I'll go ahead and just make x an integer, and I'll set x equal to whatever it returns. And whenever you can set it equal to, whenever you set x equal to it, it runs the function and then sets the return to x. And so I'll keep it like that for now. And what are we putting through here? It says we'll need to put through the array itself. So I'll just go ahead and put the array itself. And you don't need the brackets, I don't think, when you bring it through, because it's basically just a variable from this perspective. Some sort of beginning value, an ending value, and then an increment. And I'll just kind of leave those as like blank spaces for now to show that I will have to put those in, but I don't necessarily have to yet. And you can stop me at any time if you need me to like slow down or like explain something. But so with the print array, we're going to call it, and it also takes the array itself along with the size, or the number of elements, which we just set to x. So I can do it like that. And we're actually going to be doing this twice. So it says, let's see. So also under the description, you should initialize the one and only array that you declare, which is A here, by calling the function and then printing it with the function. And we're actually going to initialize it and print it twice. So first, we need to initialize it to hold the values 2 through 20, but only the even ones. And then we're going to print it. And then, secondly, we need to initialize it to hold 1 through 97. And it looks like it's multiples of 3. Not multiples of 3, but increments of 3. So 1, 4, 7, 10, etc. on to 97. And then print that. So what I'll just do is we need to set x equal to the next time we initialize it. And again, we're passing through the array itself, beginning value, an ending value, and then an increment. And then we're going to print it. We're printing the array along with however many entries we just put in. And that is the entirety of main. So I'm going to go ahead and close bracket that. And so let's kind of assume all the rest of the function looks good. Let's suppose, like, for example, we already completed initialize array and print array. We're going to theoretically say initialize array is going to work. And so let's go through main and see if this would theoretically work. So first off, we declare our array with 256 variables. And then we're saying that there's another integer x that we're going to use. Also, a good point is that all these 256 variables, they're all either, like, as soon as we declare it here, they're all either 0 or some random junk left in memory. But the initialize array is going to change that. So let's see. Right. There's an integer named x, and we're going to set x equal to the number of entries in an initialize array, because we plan on having initialize array return the number of entries that we have input. Not all 256, but just the number of entries we have input. So I'm going to start here, and what do we want the beginning value to be? I guess I'll go ahead and ask. For the first initialization, what is our beginning value? Do we want the first value to be 0 whenever we put it into the array? Two, yeah. So we want, I guess it would be the 0th. Yeah, I guess I should have asked, what would the 0th element be? Yeah, it would be 2. Right. And so, and what are we ending at? Right, it would be 20. And then what would our increment be? Right, each number adds 2. And then on our second initialization, what do we want our beginning value to be? 1, yep. And then our ending value? 97, yep. And then our increment? 3, got it. All right, so now main is complete. This is all main is going to be. And it should work if we had an initialize array and print array. But we don't yet. And I typically don't put the prototypes and then I define it at the end. I typically just put the whole thing at the beginning. But it can kind of impact readability, because theoretically you want to imagine it as your main being the main function that runs. And if you have too many functions before main, it makes it look like the code is going to run those functions first, but it's really not. And so for readability, I'll go ahead and put a prototype first and then define them at the very end. So we have int initialize array, and I'll come back to what it accepts. And then we have void print array, because it's not returning anything. It will print stuff, but printing is not the same as returning. And then I'll go ahead and kind of separate them. Oops. Here we go. And then I'll go ahead and define them down here. So int initialize and then I'll put these here for now. I'll come back to them. And now we need to tell the functions what we're putting into the functions. So here in the prototype, what type of variables are we going to be passing through this first array? We're doing 4 variables. So what types of variables are those 4? Yep, they're all integers. And so for the prototype, it's just int, 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 int. What about printing? 2 ints, yep. And those are the prototypes. However, when we're actually defining it, we need to tell it what variables they are. And this is where some interesting stuff happens. But so the first integer we put through is the array itself. And so since arrays are kind of weird, you can basically, you can't do this with normal variables, only with arrays, and what we'll learn later is pointers. But whenever you take a and I put it through this function, it literally takes the value of a, or it literally takes all the values of a, and whatever you do to it, it changes a. So a in this instance kind of acts like it had file scope. It doesn't have file scope. This is passed by reference, sort of, and I'll let Jimmer probably explain a little bit better than I could, but basically, we're putting the array through the function, and it literally changes the values of that array, which is not normal for other variables. But anyway, I'll go ahead and put int a, and it doesn't matter. I don't think even the letter here or whatever variable name we put here matters. Like I could put int array there, and I think it still does pass through the value for the entire array, and it should change it. But for simplicity's sake, I'll just say int a. And then we're taking in a bunch of other ints, and these don't matter what we call them, because inside of a function, these variables will only exist inside of this function, because these are normal variables. So I'll just say, this is the beginning, so to make it simple, I'll just name it begin. The next one was our ending, so I'll put end. And then the last one, I'll just put as I, just because I'm used to having I being an increment value. So what is Initialize Array going to do? Do we know exactly what it's going to do? Doing what? Well, that already happens, because whenever we call it, each of these variables is sent to their respective location. basically. And so what happens as soon as we call this function, the temporary variables are set. A is not temporary in this case, or at least this is not temporary. But A is set to the array, begin is set to 2, end 20, and I2. And that happens the first time we initialize it. But then again, we call it again. And so after the function runs, those extra 3 variables are just kind of tossed out. But when we initialize it again, now these variables are set to their new values. And only for the lifetime of that function. So, alright, well let's look at the Prelab and see if we can figure it out. So it's there it is, yeah, that's it. So we need to loop through all the variables of the array and basically put in our own values that we have specified. We've not specified like every single value, but we've specified the beginning, end, and an increment. Now that does sound a lot like a loop, you know. We have a beginning, an end, and an increment. Sort of, more or less, anyway. So I'll go ahead and write a for loop here. And in the beginning, this first, like before the first semicolon, this is what we want to do beforehand. And we aren't necessarily, we already have the beginning variable. The beginning variable is already set, and it's already being sent through. So let's look at the first example. 2 is set to begin. Begin is set to 2. So we already have a beginning. All of our variables have technically been set. So I'm going to go ahead and skip the first semicolon. You can do that. And I'll go on to the second part of the for loop. And so this would be our condition. The condition for which it will run. And we want this to run for every time. We want it to run until, well, I'll come back to that. But after each loop, we want to increment it. So I'll go ahead and leave that too, because I have a thought process on what I'm going to do. But we'll leave the for blank like this. A better way to do it is to fill out the inside of the for loop first. Oops. I would fill out the inside of the for loop and then figure out how many times you want it to run. So we want this to repeat for all the entries in the array. And what it's going to do is set one part of an array to a specific number. So a specific part of the array is going to be set to another number. And what those numbers are, what I'm going to do is I'm going to say that we're going to start with begin, and we want it to end at end. You can actually change these variables while they're in here. So, and it won't change the whatever. If we were to put in variables through here, it wouldn't change the value of the variables. It would only change these variables. So like, let's say, for instance, I did have another integer over here, and I called it int c. And then I set c to 2. And then here, I passed c through. The value of c is being passed to begin, and not the actual reference of c. And that's kind of the difference between, again, pass by value, pass by reference. But we're only passing through the value of 2 to begin. Begin is now set to 2. And begin runs, and this function runs. And begin, if begin changes, it's fine. But whenever it returns, c will still equal 2 at the end of here. So if we were to say printf the value of 2, or printf c, it would give us 2, even if we changed begin all around. and I'll leave it there for now. So we can actually change begin here. So what I'm going to do is we want to end at end. So I'm going to say, let's say less than or equal to end. And if we're going to be changing begin this whole time, let's say begin is going to be incremented by I, our increment. So we're going to say begin plus equals I, which is to say begin is going to equal begin plus I. So begin plus equals I is basically adding I to begin and setting begin to that value. And we're starting, and we want to end whenever begin is like, has reached the end. So at the end of our function, the variable of begin is a little, it's lying to us. Begin is no longer the beginning, you know, begin will have become the end. Yeah, you're right. So whatever element we're on, we want it to be the value of begin. It's totally fine to change begin, but if we planned on using begin again later in the function for something else, we have to realize that after this loop, begin is changed. But we don't plan on using begin again after this function. After this function, begin like dies. It gets tossed out. There's no such thing as begin outside of this function. But C will still equal to after here. So I'll go ahead and printf. This. So I'll printf whatever C equals after we initialize the array, just so that we can have a little bit more clarity on what's going on. But we're changing begin, but C won't change here. And it's completely fine to change any of the variables in here. In fact, our goal is to change A. We want to set A to these different things. So, well, what value are we changing? So let's look through this program and see what it's going to do. So we're going to start a begin, and we're going to set A. We're going to start with A0. We're going to start with A0, and then we're going to set A0 to whatever begin is. Then we're going to loop back, and now we're on the first element. And we want to set it, begin is incremented by the increment. So begin is no longer 2, it will become 4. And then it'll run, and now we want the first element to be 4, which is begin. And then the loop runs again. A should be turned to 2. Do you see what's happening here? There's like another increment that's going to be going by 1 each time. And so there are a few ways we could do this. But I'm going to do what I did, which is I'm actually going to go ahead and define something here. And I'm going to say int counter. We're going to set counter equal to 0. And so now we're going to start with a nice variable here that's going to be 0. So we want A0 to start with begin. Once it's going to go to the next one, we want counter to increase again. And then when counter is 1, we're setting A1, A sub 1, to the next value of begin. And so also after each of the loop, we can put a comma after here instead of a semicolon. And both of these will run at the end of the function. So I can do counter plus plus, which will increment counter by 1. And so both of these expressions, both of these assignments will occur at the end of each for loop. You can do that with a comma. So now let's see what we have here. We have counter set to 0 for the first time we run it. let's say we're going to initialize it for the first time. A is literally the array that we have set. Begin is 2, not C, it's 2. End is 20, I is 2. So now on the for loop, until begin is less than or equal to our ending value. And since ending value isn't changing, we can go ahead and pretend like end here says 20. So until begin becomes greater than end, basically. Until begin becomes greater than end, we're going to do the loop, and then increment begin by our increment, and add 1 to the counter. So for our first one, counter is 0, begin is 2, so A0 is 2. Alright, then we loop back up, counter plus 1, begin plus our increment, so begin is now 4, so A1 is 4. Alright, so now it's going to work pretty well. Now we get to, I believe it's technically the 10th element that we've put in, but it's going to be labeled as A9. So A9 is going to equal 20, because by that time, begin is still equal to end, because begin is going to equal 20, and end is 20, and since they're equal, it's fine. It'll run this, and so A9 will be set to 20, and then begin will be raised again by 2. So now begin is 22, and when it tries to run the for loop again, it stops, because begin is no longer less than or equal to end. And so it finishes the function. It finishes the for loop, and since we don't have anything left in the function can end. And so, as you can see, we've successfully filled the values of A from beginning to end. And at the end of this function, begin, end, and I are all tossed out. The problem is we still need to return something. So before we toss everything out, we need to return something. Any idea of what we should return? We need to return the number of entries that we just put into our array. So how are we going to do that? If you return the array itself, what that'll do here is we're going to set, that would set x equal to the array. So x would basically become the array. But we don't, and that'll kind of be a little bit, it'll cause a few errors. So we don't, we could return the counter, because as you remember, our counter was literally counting up the number of entries. So when we return counter, after the final loop, what is going to be the value of counter? Yes, and which would that be? Begin would be 20. It would be 9. Yes. Right. So we will return counter, which will be, at this point, 9. So the problem with this is that 9 is not technically our number of entries. 9 is the 10th element, really, because we started with 0. So we're going from 0 to 9, and those are 10 numbers. I'll leave it as that for now. We can use it. It'll still be fine. But we have to remember, it depends on what you want to do. You could either return 9, or you could just add 1. And it's super simple. You return, this would literally equal the amount of elements that are in the array that we had entered. But depending on what we do in print array, we don't need that. And so I'll come back to it. We just need to remember that currently, counter is 9. And when we return counter, that stops the function. Counter is actually thrown away because it's only here. It's only defined here. Actually, I should put it before here. Because if you look at what's happening here, counter only exists within this loop here. Because after this for loop, since I've defined it here, counter would have been thrown out at the end of that for loop. I don't want counter to be thrown out, so I'll define it before the for loop. That way it'll remain for the function. Does that make sense? Okay. Yeah, because otherwise I think it would only exist within the for loop, and then we wouldn't even be able to return it. It would just be thrown out. Right. Right. And we wouldn't be able to return it had I only declared it in here. So what happens as soon as we return counter? Well, we know counter at this point is 9, so we are returning literally the value of 9. So this entire expression here, this ran the function, and first off, it literally changed the value of A, the values inside of A, because A is special, it's an array, it's allowed to change within the function. C was not changed because it's a normal variable. And all of this together is equal to whatever we returned, which in this case is counter, which in this case is 9. And so all of that equals 9. So we're setting x equal to 9. Do you see that? Awesome. And now counter has been thrown out, begin, end, and I have been thrown out. We no longer have them at this point in the code. We still have A, because A is the array that we've actually called here. This is where A lives, but it kind of took a vacation over here when we called it over there. Arrays can do that because they're special. Same with pointers that you'll learn eventually, but it gets complicated. So x equals 9. We've now successfully set x to the number -1 of elements we've put into A. So this means that currently, what are the values of A? So, yeah, what are the values of A that we've just put in? Yeah, so each of the beginning of A, so A0 is A sub 0 is 2. It goes all the way up to A sub 9, which is 20. But we can't forget that all the rest of the variables after that. So what is A sub 100? A random number or 0. Yeah, exactly. But we don't really have to worry about that because for our print array function, we're giving it a stopping point, basically. We want it to spit out, basically, all the numbers of the array that we have just entered. And we have what we've just entered, it's x. X is 9. So we're giving the print array function, we're giving it the array, so it can look through the array and literally see all these values. And it's going to print each value one by one until it reaches A sub x. Does that make sense? Alright. So let's go ahead and we'll go ahead and do this here. So we want print array to print each number. And so this is going to be a loop as well. In fact, it's going to be very similar. So first off, let's actually put our variables up here. Let's not forget that. So we're starting with int a, of course. That's our array that we're sending through. But we're also sending through x. And if I were to say put int x here, this value of x would temporarily, it would be different than this x. So if we sent x through here, we could change x all we want, but it won't change this x. but for simplicity's sake, I'll go ahead and say that this is instead, how about we set it to max? Because that's going to be our max, where we want to stop. And so we're going to have another for loop. I'll just put it like this for now so we can figure it out. Inside of this for loop, so for each of these values, we're going to print it. So we're going to say, we're going to printf a sub whatever number we're on is equal to whatever that value is. And then new line. And so first off, for each of these loops, these two numbers are going to change. So we want to put a sub whatever number we're on is equal to that specific value. So in this case, I'll save a sub blank for now. I'll leave that blank. But the value at that point is whatever a sub whatever is. Does that make sense? I think it would make more sense if I actually finished the for loop. But because we're basically missing something here. We don't have a variable that we can put through here, because if we were to just put max through here, if we wanted a sub max, that would only give us, well, the maximum, it would give us a sub 9. Because remember, what we've just passed through here, what we just passed through here is 9. Initialize array it ended and it was set to 9, x was set to 9. Now we're printing array, x is 9, we're sending the value 9 over here to max. Max in this function is currently 9. So if we were to just say max here, if we just wanted it to be max, it wouldn't really work, because then it would always be a sub 9. And then, like, a sub max is always going to be whatever a sub 9 is, which is always going to be 20. So we can't use max. We're going to have to use a different variable. And for here, we can just reuse I. Because remember, here, I was thrown out. So I'll say there's an integer. We have to redeclare it because it was thrown out. There's an integer called I, and I'm going to set it to 0. That's what we're going to do at the beginning. And we want to increment it until we get to the max. So until I is greater than max. That's how I typically read the condition. It says while, basically while I is less than or equal to max, it does the for loop. I think of it that way, and I think of it as like the opposite. So until I is greater than max. That's another way of looking at it. But it also kind of complicates things, so look at it however you need to look at it to make sense. So yeah, while I is less than or equal to max, it'll run the function, and at the end of the function, we're going to increment I by 1. So now what happens is on our first run of the function, I is going to be 0. It's going to print whatever the thing is, and then it's going to increment by 1. Now I is 1. Then it goes to 2, 3, 4, 5, all the way up until, so on the last run of the function, when I is equal to 9, 9 equals 9, so it's fine. So we're printing it, but whenever I is incremented again to 10, now 10 is greater than max, and the for loop stops. And since this is a void function, we don't need to return anything. We can just end it. But let's see what we need to do in here. We want to look at a sub 0 all the way up to a sub 9. And we can do that pretty easily because now we have a variable that is actually equal to that. So instead of max, we're going to say I, and then a sub I. So now we have I is 0. For each loop at the end of it, we're going to increment it by 1, and we're going to keep doing this until I is greater than max. So printf, we're printing a sub whatever I is, So the first one is 0. A sub I is equal to whatever A sub I is, which in this case, A sub 0 would give us 2. So it'll literally print A sub 0 equals 2. Then it'll go on a new line. I is incremented. We're now on I equals 1. It's less than max, so we're fine. So I sub, or what did I say? I should be 1, because we went from 0 to 1. Sorry, my apologies. We went from 0 to 1. Now we're on A sub 1. A sub 1 is, of course, 4. And as you can see, it's going to increase until we're at I is 9. Oh no. That's Tiger Wi-Fi for you. Can you guys still hear me? Can you guys still see the putty? Okay. Well, rather unfortunately, I was just disconnected from putty. So I'm going to attempt to, let me see what I can do. I could probably bring it back. Let's see. Oops, hold on. But are you guys understanding what's happening so far? Okay, awesome. Yeah, no problem. Mm-hmm. Mm-hmm. No. It will be different. I'm reusing I because at the end of Initialize Array, whenever we put I there, it currently has the scope of that particular function. So its lifetime ends whenever that function ends. So as soon as we return counter, the variable I is no longer needed and it is completely thrown out and discarded. Right, and we're not actually using the variable counter because remember that at the end that variable is actually thrown away. It's just that that value has been put into X, and X was put into print array. And so, yeah, it's only values. I in print array is kind of like the counter, right? Yeah. We could probably look at that, yeah. Let me actually see if it saved. Let's see. So, whenever I lost internet, I was editing the file. It says, we found a file that you're editing. Another program is editing. Be careful not to end it with 2 instances. I think I could recover it. Let me see. Oh yeah, while opening, an edit session for this file crashed. If this is the case, recover. Alright, I'll try and recover. Recovery completed. Let's check to see if everything's alright. Yeah, most of everything is still here. Okay, can you guys, so am I sharing the right screen or you still see the old putty? Okay, 1 second. How about now? Okay. I'll get rid of the old one. Alright, so this is, wherever the cursor is, this is definitely the new putty. So let's see, did we lose anything? I don't think we lost anything, because I was explaining for so long. Alright, yeah, okay, sweet. So, right, so at the very end, when I is 9, a sub 9 is equal to whatever a sub 9 is, which is 20. I is incremented to 10, max is 9, 10 is greater than 9, so it stops, for loop ends, and we're done printing. That make sense? Max is 9, because we'll start at initialize array again. Whatever we return from a function is set to whatever this whole expression is. This entire expression here is whatever has been returned. And what have we returned? We have returned 9, because at the end of this whole loop here, counter 0, at the end of each loop we increment counter by 1. It took us 10 elements, but it starts at 0, so it ends at 9. Counter is now equal to 9. We are not returning counter, but we're returning the value of counter, which is 9. All these variables are lost, but the value 9 is now put here. X is now set to that value, which is 9. So now X is 9. After this line here, X is 9. We could actually, I'm going to go ahead and printf, let's see here, X equals, just so that we can figure out what X equals as well. So we're given that C is going to be the same, C is not changed, but X is going to equal 9 at that point. And it's a good idea to include printf so that you can understand what's occurring at each step. But alright, so X is 9, because it's returned 9, and now we're setting it to X. Whenever we go to print array here, this is our function. We're passing through the array itself, and X, but not really X, just the value of X. And since X is 9, we're passing X down, and it's put in here to max. So max is now equal to the value of X, which is 9. Does that make sense? Okay, good. And that's why max is 9, and whenever I is 10, it stops the for loop. And now we basically got it. We've done everything in pretty general terms. We haven't been specific for any of our loops. So that means, theoretically, we could change beginning, end, and I around all we want, and we should always return the correct number of entries, and it should, theoretically, when it prints, print each element correctly. Which means we've tested it out for our first calling of initialize array. So after here, after we've printed the array should print well. And it'll stop printing as soon as we get to the max. So it won't print all 256, it'll only print until we get to the max. Now we're on this line here. Once again, we're basically repeating this line, but with different numbers here. So let's see what happens. Let's first test out initialize array. And remember that X is going to be set to whatever the return value is. So A is set to A is A. Because it's an array, A is A. Begin is set to 1, end is set to 97, and I is set to 3. And so now this function has been brought back to life. All of its old variables don't remain there. It's not really brought back to life, it's basically recreated. And so all these variables, it's like they're new. They haven't been born before, they're just new. And so counter now comes into existence, and when it comes into existence, as soon as we've declared it, it doesn't have a value. So it's either going to be junk from memory, that whatever's there, because it's new. It's a new variable that we've not used before. That's what the code thinks. So we're setting it to 0. Beginning is, again, we set it to 1. So until beginning is, until beginning is greater than end, we're going to run this, and at the end we're going to increment begin by our increment and add 1 to our counter. Counter will always be incremented by 1 because it's just counter plus plus, but begin, whatever, so 1, it's going to be incremented by our increment 3. So at the end of this first loop, begin is going to become 4, and the next loop it's going to become 7, and then 10, and so on, until we have begin. Whenever begin has been incremented enough, sometime in the future, it will become 97. At that point, it will run its final loop, and then at the end of that loop, it becomes 100. And then when begin is 100, it is now greater than end, so that fails, or that conditional fails. And now the for loop is done, and we return whatever the counter is. Now real quickly, what is going to be the counter after we've gone through all this? Do we know? That will be the value of a subcounter. 32, yes, I believe so. Yeah. Mm-hmm. And at that point, after it's done 32 loops, begin will be greater than 97 and it'll end, and we return counter. Yeah. Let me think for just one moment. I feel like I'm missing something. Where? Oh, yep, you're right. Good catch. I'm going to think again on this counter thing. I think it should be correct, but I might be off by 1, because at the end of the for loop, it increments both begin and counter. So if we were to increment counter, so let's start again. Counter is 0. I'll start with the first one because it's pretty simple. I want to double check that my counter is correct. So counter is 0. Begin is 2. End is 20. Increment is 2. So a sub 0's 2. So I'm going to count up on my fingers. I know it's kind of silly, but I'm going to just... Sometimes whenever you're debugging, it helps to like write it down and figure out step by step what's going on, or just add a bunch of printfs. But we haven't even run the code yet. We haven't even run the code yet. I just want to make sure everything looks fine and dandy. But I think at the end, because a sub 9 is set to 20, and then at the end of that loop, it's going to actually increment begin and counter. So begin is going to become 22, and counter is actually going to become 10. And then it checks the conditional. And the conditional says, oh, begin is greater than 20, so we're going to stop it. That means that counter at this point is actually 10. I had neglected to remember that earlier, but counter is incremented along with begin. So counter would actually be 10. Do you see how I made that mistake? Alright, so for each loop has a specific kind of process it goes through. First off, if I were to write everything that wasn't, if I were to write it in the way that it wasn't a for loop, counter equals 0 would go before. Counter equals 0 is the first thing to run in a for loop. And then the loops actually occur. This one thing is only run once. We don't come back to counter equals 0 after we start the for loop. So counter is 0 at the very beginning. Now, we're going to check to see if begin is less than or equal to end. And if it is, in this case. 2 is less than or equal to 20. We're going to go ahead and run the function. and the function is, or not, we're not going to run the function, we're just going to run the for loop, which in this case is setting a sub counter to begin. So counter 0, a sub counter is 2. A sub 0 is 2. At the end of that loop, it increments both begin and counter. Begin is going to be added, or increment is going to be added to begin, and counter is just going to be added by 1. So that always occurs at the end of a loop. And see, in this case, at the end of that loop, we have not rechecked to see if beginning is less than or equal to end. This just happens at the end of that for loop. At the end of this individual loop. Does that make sense? Yes, it increases by 1. Counter will increase by 1 all the time after this line here. You could imagine that at the end of each for loop, they have basically put in our code for us, which is begin plus equals I and counter plus plus. But the problem with that is, it then goes back up to check the conditional. So let's go to counter is 9. So let's run this. Let's run it from the start, or let's say counter is 9, and let's say at this point begin is already 20. So 20 is equal to end. It's still correct. It's still true. So it's going to run one more time. And so after it checks the conditional is true. It runs through the function. It runs through the for loop. A sub 9, we're on 9. A sub 9 is equal to 20. That is run. And remember, at the end of each loop, it increments. So it's going to run both of these. So it was a sub 9 is 20. Now we have 22 and 10. Begin is now 22. Counter is now 10. And so then it goes back and checks the conditional. Now we have 22 is less than or equal to end. Or 22 is less than or equal to 20. That's false. So now we break out of the for loop. But that didn't stop counter from counting up. See what I mean? It wouldn't, right? Because it would say, because at this point, when the conditional fails, it stops the loop and skips immediately to this end bracket. It'll only run the loop if this is true. If this ends up being false, it skips all of this entirely and goes to after the bracket. And since 22 is not less than or equal to 20, it does not print whatever counter or begin is, and it goes to the next one. But the problem is that when we return counter at the end of the loop has still incremented, and it's 10. Yeah. Or you could do counter minus 1, because we want it to actually be 9. Or even like down here, we could say, we could actually add, like subtract it here, you know, whatever was returned, we could say minus 1, or even here, we could even put x minus 1 is what we want to send through. But I'm going to opt for returning counter minus 1. This will properly return 9. And see, that's why we have this debug here, this debugging printf here, is if we were to run this, we would figure out that x was actually 10 before we fixed our little error here. You could do that too, actually. That would work. Actually, no, because if you did it like that, let's say we did begin is less than end. This means that, well, our end is set to 97, or sorry, for our first one, to 20. So end is 20 at this point. If begin becomes 20, at that point, begin is not less than, or 20 is not less than 20. 20 is 20. So it would completely skip this entirely. And it wouldn't say a sub 9 is 20. Begin would be 20, but it would not run what's inside here. Counter would be 9, because it ends prematurely, but begin would be 20, and it would not print this, because 20 is not less than 20, so it skips with the interior of the loop. Does that make sense? Okay. Oh, here? I guess we could, yeah. Right. That's totally true, because if max is going to be 10, let's say we didn't subtract anything over here, counter plus plus, it ends up being counters 10. It puts 10 into this value, 10 turns into x, x is equal to 10. Now we're passing the value 10 over to max. Now max is 10. And we want it to stop at the 9th value, really, because we're starting at 0. We don't want to do a sub 10. We only want to do a sub 9. So at the end of here, we've done a sub 9. We go back up, we increment I by 1. I is now 10. 10 is not less than 10, so it skips the loop entirely. You're correct. So just by removing that equal sign there, we fixed our error. We don't even need to subtract anything. Another thing, yeah, that'll do it, yeah. So I'm actually going to go ahead, before I lose it again, is I'm just going to write it. I'll just write it for now. And so theoretically, we're golden. Yep, we already made the prototype for that. Yep. Still need, yes. It depends on where you're defining your function. And again, I've defined my functions under main, because for readability it helps a lot. You're just saying that these exist, we'll get back to them, and then down here they are. If main is first, it helps with like readability, because you're like, okay, main is running, it's what runs. If you were to have these functions first, you could totally skip these entirely if you just moved these functions up to before main. You could do that, it's totally legal. But if you did that, it would just kind of, it would hinder readability, because then you'd be like, you'd go through the function, and like, I feel like subconsciously it would make you think that they would run before main, which isn't true. Main is what runs first. These functions only run whenever we call them. And I think it just helps for readability, but you could put them up there. It's totally fine. Do we want to see what this runs like? All right, let's see. All right, let's see what we got here. And I'm not immune to errors either. But let's start here. So passing argument makes an integer from pointer. With that. Okay. So makes an integer from pointer. This is not actually what I did for my Prelab. I'll show you a thing I did in my Prelab that kind of simplifies things a bit. Oh. So what I did in my Prelab, so in here we've set x to whatever the value of that we've returned, right? So we've returned whatever counter is, and theoretically we're trying to set that to x. But there's an easier way of doing this. See, because what we've done here is in our print array we're just calling, we're just giving it, we're passing through the value of x. But the value of x is simply this expression here. So what we could do is just put that entire expression and replace it, which I'm going to do that right now, and we'll see what happens. And I'm going to go ahead and make it look a little bit neater. I'll go ahead and print these out. Let me actually take this line here and see if I can. Okay, so we can do this. It's entirely legal. We can simply pass through printArray our call to initializeArray. Because remember, that's going to end up being a value. And the value of initializeArray, for this one in particular, ends up being 9. So we're skipping x entirely. And I feel like that would make things a little bit more simple. It looks a bit more complicated, but in reality it's actually more simple because you're not using as many variables. So I'll go ahead and do that. Huh? What I did is, if you highlight, so whatever you highlight, if you press Y, it yanks that. And then wherever you go to, if you press P for paste, it pastes it right after that, wherever your cursor was. And you have to do that in the visual mode, which is where you can like scroll through and tap through, and that's when you do the :W and stuff like that. Yeah, you have to press escape for that. See, because if I were in insert mode, if I pressed Y, it would, it would not work. You got to press escape and then highlight, then Y, etc. But this fixes up the X issue. I didn't actually know you couldn't put. Well, I could have done something wrong somewhere. I don't know entirely, but let's run it again and see what happens. Because oh, this was lost. Okay, hold on. There we go. Refix that error. Remember the equal sign. For some reason, it did not like our code. But I'll go ahead and try and run it again and see what happens, or compile it again and see what happens. Okay. So passing still doesn't like that, huh? Passing argument 1. Argument 1. Argument 1 here is this, and it expected an int, but it's actually a pointer. Oh, I think. Okay. Okay, I think I know what's going on. I think. Oh, why is it doing that? That's annoying. Well, let me check through and let me fix all the errors that we had been fixing. Oh, and it didn't keep this either. Okay, I have an idea. I'm going to go ahead and quit. I'm going to, let's see. There's a command for renaming a file. I could, but you can't. I don't think you can yank through 2 vims. That's what I'm thinking. Mm-hmm. And I think if you try to do command, or if on my computer, Control C would be copy. But if you remember, Control C is also the command to quit running the code. Oh, okay, I got it. So it would be, it's actually going to be move 36, and we want it to be called, let's just do pre6-3. Let's see here. Okay, let's attempt. Yeah. Okay, that one worked. So all I did there was move it. See, it's the move. Basically, I moved it from pre6-2 to pre6-3. and that deletes prefix-2. It doesn't copy it. I know there's a copy function as well, or copy command as well, but I just moved it. It still worked. So prefix-3 completely works. I think it solves the issue of when we disconnected. I hope it does at least. So let me go back and figure out what errors need to be changed again. So, okay, I is less than max, that's fine. Oh, this is weird. It actually kept our changes. Well, I'll just ignore that then. That's fine. I think we're good. I'll go ahead and try and compile it again. Okay, so let's see. So, right, it was doing the, didn't like that we had initialized. Okay, hold on. So up here, we have basically told initializeArray and printArray that, hey, we're going to send through an integer. But it's not really true because the array is special. It's an integer, but it's a bunch of integers, and it's actually different. So if I were to actually instead say that we're passing through an array, oops, not what I meant to do. If we just say here we're passing through an array, it'll probably solve its problem. Because it's yelling at us because an array is not really an integer, it's a collection of integers. And it references them based on their location in memory, but I think this should solve the problem. By naming it here and telling it with these brackets that it is in fact an array, I believe it should fix the problem. Oops. Let's see. Oh goodness. Hold on. Let me. Okay. Now we can just go to the top of the screen and. Oh, is it not gonna? Okay, hold on. I did. Okay. Here's where. Yeah. So our first error is conflicting types for. Okay. So here we've said, and we previously defined it. Okay, we got to do that for both places. So down here as well, we've actually got to put the brackets. And then down here as well. Because an integer and an array are different, you have to kind of help it out. Okay, now we've only got one. Oh, we missed a. It didn't fix our error from before when we did the printf. Here we go. There we go. Okay, so all those errors were just telling us whenever we use this here, whenever we prototype it, we have to tell it that it's an array, and for each of these two, we have to use the brackets. And then I just forgot the semicolon there. All right. There we go. Okay. Now let's see what it runs. Look there. All right. And yet we also did our C equals right there as well. So as we can see, for our first one, A0 is 2, it goes all the way up to A9 is 20. And our second one, A0 is 1, goes all the way up to A32 is 97. And see how we didn't even tell it to stop at 32? We told it to stop at max, which was determined by this number here, essentially. But we've successfully made the entire code. At the end, we kind of jumped around there with the x equals. So do you have any questions about what I did at the end there to fix things? Is everyone fine with what happened? All right, yeah, that's a good question. So we need to figure out in main because in main we need to print those headers. So where in main would we do that? We would do it right before we print the array itself. So in that case, literally here. So I'll go ahead and printf array1. And then right before we print the second one, we're going to printf array2. And you could see that C did not change. So I'll go ahead and simplify it a little bit further and just get rid of C completely. Oops. Ah, oh, darn. U is undo if you ever mess anything up. Okay. There we go. So I've gotten rid of C. Now I literally put 2 in there. Helps it out a little bit. Also for a little bit of readability, on our printf function here, on our print array function, what I'm actually going to do is I'm going to go ahead and put a tab right before we do this. And \t is a tab. So \n is new line, but \t is a tab. And so I'll go ahead and show you what that looks like. See how it's actually tabbed over now? But there you have it. Mm-hmm. Right, okay, so I don't, it's kind of weird, and again, we haven't learned this completely, but you don't need the brackets when you send it through, when you call it. For some reason, I don't know quite why, you don't need the brackets when you have it in here, but you do need the brackets in your definition. And I think that's because in the definition, there's no way to really tell between an integer or an array unless you put the fact that it's an array here. And so A here is the array itself. Whenever we deal with the array here, we know that A is an array because we've declared it as an array. And so if we were to just printf, or if we were to send A through, send the variable or the array called A through, it's going to send, it knows it's an array. But here, since we only had the A here, it would act as begin and an I. It would say, oh, so I need to create a variable called A, and this A is going to be temporary for this program. That's what our function is going to do. We don't want it to create a variable. We want it to use our array. And so we have to tell it, use the array. I think that's probably the best way I could probably explain why we have to put the brackets there and not there, you know? Yeah. Yeah. Exactly, because the function doesn't see A because it was only defined in main. The way to make it see A is to let it know, hey, there's an array coming. Yeah. Well, what we have here, so when we call print array, we pass through the two values. Of course, A is not being passed through as a value, it's being passed through as the entire array itself, because it's an array, and arrays are special. You don't pass through the value of an array. If we wanted to pass through the value of an array, we could totally do that. A sub 2, that would pass through the value of A sub 2. But by passing through A itself, that makes it so that it's passing through the entire array. But in this second one here, remember this is going to be equal to whatever counter was, in this case 32. So print array here is sending through the array called A and the value 32. And they're sent down, so the array called A has been met here, and it's fine. And the value of 32 has been sent to the integer max. So the integer max has been set to 32 in this case. And so for this function, max is going to equal 32. Awesome. Yeah. Size of the array as well. Oh, it does. Yeah, I'll fix that there and just make it a little bit more sense. Mm-hmm. Yeah. That's true. But yep. Yeah. Yeah. I don't know. Yeah, I don't know how the lab would go if we hadn't learned, like in this little specific things, like where here you don't use the brackets and here you do use the brackets. Like lab would suck if you didn't know like that little specific thing, you know. Mm-hmm. Mm. You know, I mean, I'm enjoying the class besides this. This is a very weird... It's weird that it wasn't fully explained before the lab itself started, you know? Mm. Oh, really interesting. Yeah, that's true. Well, to him, yeah. Right. Mm-hmm. Yeah. That's for sure. Yeah. I can feel that. Mm-hmm. Implicit. Mm-hmm. Yeah, I could. I probably could, yeah. I'm... Sweet. Yeah. Yeah. Yeah, of course. Yeah, I could probably stop sharing my screen and we'll see what you have.